Hello everyone. Let us see the solutions for Uttarakhand Public Service Commission, Deputy Superintendent of Police, Telecommunication, 2024 ECE question paper solutions, part 1. First question. Which of the following is not a method to grow the crystals? Jig-Charlesky method, Bridgman method, liquid phase Copernicus method, liquid encapsulated Charlesky method. So, in the question he has mentioned which is not a method. So, not a method is Copernicus method. So option A, option B, option D are these are the methods used to grow the crystals. Let us see some of the methods used to grow the crystals are Jig-Charlesky method, silicon float zone technique, Bridgman method, liquid encapsulated Charlesky method. So this liquid phase Copernicus method, it is not a method to grow the crystals. Next question. An unstable multivibrator is it is nothing but a square wave generator. A stable multivibrator is a square wave generator or a free running oscillator or FSK generator. So monostable multivibrator, the applications of monostable multivibrator are pulse stretcher, missing pulse detector, frequency divider, linear ramp generator. Correct option is 2. Next question. Which of the following is not an infinity for an ideal amplifier? So in the question it has been mentioned what are the characteristics of ideal amplifier. So let us see the characteristics of ideal amplifier. Voltage gain is infinity. Input resistance of ideal amplifier is infinity. Output resistance is 0. Bandwidth is infinity. CMR or common mode rejection ratio is infinity. Slew rate for ideal op amp is infinity. The drift with temperature is 0. Supply voltage rejection ratio is 0 and offset is 0. For ideal amplifier, output resistance, drift with temperature, SVRR, supply voltage rejection ratio and offset is 0. Rest all the parameters are infinity. So in the question, which is not an infinity, so that is input impedance is infinity, output impedance is 0, open loop gain is infinity, frequency bandwidth is infinity. So correct option is B. The output impedance of an ideal amplifier is 0. So this means if output impedance is 0, the amount of current drawn by external load, the output voltage of operational amplifier remains unaffected. So that is there is no loading occurs. If output impedance of ideal amplifier is 0, regardless of amount of current drawn by the external load, the output voltage remains unaffected. Output voltage is constant. So that is no loading effect occurs if output impedance is 0. So that means even if load draws more current, the output voltage of amplifier does not change, remains constant. So correct option is B. Next question. For an amplifier having gain A, feedback ratio beta, the Bark-Hassan criterion for sustained oscillations is. So correct option is according to Bark-Hassan criteria, the magnitude of loop gain, that is A beta, where A is amplifier gain and beta is a feedback gain. So the product of these two is unity. If A beta is equal to 1, then oscillations are sustained, that is amplitude of sinusoidal oscillations remains constant. And the second condition of Bark-Hassan criteria is total phase shift around the closed loop is 0 degrees or 360 degrees. Mod A beta is equal to 1. So correct option is D. Next question. The voltage that start an oscillator is caused by. So the voltage to start an oscillator is caused by noise. Because for oscillator, no input signal is applied. For oscillator circuit, it produces oscillations without any input. No input is applied to oscillator circuit, but it produces oscillations. The reason for producing oscillations is noise caused within the internal circuitry of the oscillator. So thermal noise and amplifier noise. So every electronic circuit generates small amount of random noise due to thermal agitation of electrons, that is thermal noise. Amplifier noise, because of active components like transistor and operational amplifiers, contribute some more additional noise. This noise serve as an initial input signal which is then amplified, fed back by an oscillator circuit. The feedback loop sustains and increases the oscillations. The feedback loop sustains and increases the oscillations until desired steady state amplitude is reached. So therefore, for an oscillator circuit without any input signal, it is producing oscillations because the initial input signal to the oscillator is noise, internal noise generated within the active and passive components of the oscillator. So correct option is B. So it is producing oscillations because the noise voltage in the resistor. The voltage that starts an oscillator is caused by noise voltage in the resistor. This noise voltage is created by random movement of electrons in a resistor at room temperature. Correct option is B. Next question. The Wien-Bridge oscillator is useful for this RC phase shift oscillator and Wien-Bridge oscillator are audio frequency oscillators whereas LC oscillators like Hartley oscillator, Colpitt's oscillator, crystal oscillator are radio frequency oscillators. These are high frequency oscillators. And this RC phase shift and Wien bridge are low frequency oscillators. Now the correct option is 1. That is A. Wien bridge oscillator is useful at low frequencies. Next question. The output waveform of a 555 timer is rectangular. So this 555 timer can be operated in two modes of operation. That is astable mode. 555 timer has astable mode and 555 timer has monostable mode of operation. In monostable multivibrator using 555 timer, it can produce much longer rectangular waveform. In a stable multivibrator using 555 timer can generate rectangular wave, and then after the adjustment of resistance, that rectangular wave is converted into square wave. So rectangular wave or square wave, generally it is a rectangular wave. Let us see the time period of on-state duration for an unstable multivibrator using 555 timer is T1 is equal to, this is on-state time duration, T1 is equal to 0.693 R1 plus R2 into C1, and off-state time duration T2 is equal to 0.693 R2 C1. The total time period is T1 plus T2. It generates a rectangular waveform. If R2 is based on the adjustment of resistors, then this rectangular waveform can be converted into square waveform. So correct option is C, rectangular waveform. Next question. The voltage gain of operational amplifier is, the voltage gain of an op amp is unity at dash frequency, at unity gain frequency. The frequency at which the gain of op amp is 0 dB is called unity gain frequency. So that is, this frequency corresponds this frequency unity gain frequency corresponds to the gain of unity, or the frequency at which magnitude is equal to 1 is called unity gain frequency. Correct option is B. So voltage gain of op amp is unity. It is unity gain frequency. Next question. The noise temperature in a communication system is 4306 Kelvin. Find the noise figure. In the question, they have mentioned equivalent noise temperature T is equal to 4306 Kelvin, and the relation between equivalent noise temperature and noise figure is T is equal to T naught into noise figure minus 1, where T naught is reference temperature at room Kelvin, that is at 17 degrees centigrade. So convert this 17 degrees centigrade into Kelvin plus 17 degree, so it is 290 Kelvin. So T naught reference temperature is 290 Kelvin. Substitute T naught and TE in the above expression. TE is 4306, T naught is 290, noise figure minus 1. Now noise figure is equal to 4306 divided by 290 plus 1. So its value is 15.848. Now apply natural logarithm log of 15.848. So it is given 1.10 log of, so 10 into the given log 15.848 is 1.199. So multiply with 10. So that is 11.99 dB, approximately equal to 12 dB. So noise figure is 12 dB, or noise figure is 15.848. So correct option is C. Next question. A memoryless source emits M1 M2 symbols with two probabilities 0.8 and 0.2 respectively. Find the code efficiency if the source symbols are coded using Hoffman coding for second order extension. Hoffman coding for second order extension. So let us see the message probability. Let us see the Hoffman coding for two messages M1 and M2. So for message M1 probability is 0.8, for message M2 probability is 0.2. Now here it is code is 0, here it is 1. So code is 0, here it is 1, code length is 1 1. Now find the entropy of the source. That is entropy formula is H is equal to sigma I is equal to 1 to n pi log to 1 by pi, where pi is the probability of ith symbol. The expression can be rearranged as sigma I is equal to 1 to n minus pi log to pi. So that is sigma. So P1 is P1 minus P1 log to P1 minus P2 log to P2. Substitute P1 and P2 values here. Minus 0.8 log to 0.8, that is 8 is 2 cube, minus P2 0.2 log to 0.2. Its value is 0.72. So the entropy is 0.72. Next is code length, average length, L bar. So average length L bar is equal to sigma pi Li. So that is P1 code length L1, probability of symbol 2 code length L2. So probability of symbol 1 is 0.8 and code length is 1. Plus probability of symbol 2 is 0.2 and code length is 1. So average code length is 1. Now see the efficiency. Efficiency is the ratio of entropy to average code length. So that is entropy is 0.72 and average code length is 1. Now the efficiency is 72%. So this is first order extension. So in the question it has been mentioned second order extension. For second order extension, M1 there are two message symbols M1 and M2. There are for 2 bits, 2 symbols, there will be 4 probabilities. 4 messages are M1 M1, M1 M2, M2 M1 and M2 M2. These are the 4 possibilities and the probabilities, corresponding probabilities are 0.64, 0.16, 0.16 and for last symbol it is 0.04. So let us do the Hoffman coding for this group of 4 possible symbols in the second order extension. So first one is 0.64. 0.16 plus 0.64 is, it is 0.2. So apply Hoffman coding procedure. The remaining is 0.16. So this is 0.16. Next 0.64, 0.20 plus 0.16, that is 0.36. Now start assigning the bits. So here it is 0, here it is 1, here it is 0, here it is 1, here it is 0 and 1. Now bring this 1 to here, 1 0 1 1. So next this 1 0 to this position. So let us assume this is symbol x1, symbol x2, symbol x3, symbol x4. For symbol x1, code is 0. For symbol x2, code is 1 1. It is a code is 1 1. For symbol x3, the code is 1 0 0. For x4, it is 1 0 1. Now code length 1 2 3 and 3. From this calculate average code length. L bar is equal to, so we know that from first order expression entropy H is equal to 0.72. Now calculate the average code length. L bar is equal to P1 L1. So probability of symbol x1, that is 0.64 into L1. Second probability 0.16 into L1. Third symbol probability 0.16 into length is 3. Next fourth symbol probability is 0.04 and its length is 3. So now after calculation, this average code length is 1.56 bits. Now L bar is equal to, this is L dash. So average code length L bar is equal to L dash by 2 because it is a second order extension. So 1.56 by 2, it is 0.78. This is average code length. Now efficiency is entropy 0.72 by average code length L bar 0.78. So its efficiency is 92.3%. Similarly, for third order extension, there are 8 combinations are possible, and follow the same procedure. After calculation, efficiency is 98.9%. If order increases, for no order extension, for no extension, efficiency is 72%. For first order extension, efficiency is 92.3%. For second order, it is 98.9%. So that means as the order of extension increases, the better will become the Hoffman coding. The question, what is the efficiency of second order extension? The efficiency is 92.3%. So correct option is A. Next question. The satellite used for intercontinental communications are DoSat, ComSat, Marisat and Intelsat. So the correct option is D. Intelsat, International Telecommunications Satellite Organization. These satellites are used for intercontinental communication. So Marisat, Maritime Satellite System, DOMSAT, Domestic Satellite Communication System, and ComSat, Communication Satellite Organizations. So these domestic satellites are used for within the country or within a region. So the correct option is D. Intelsat satellites are used for intercontinental communications. Next question. Quantization noise occurs in TDM, FDM, PWM, PCM. So correct option here is PCM. Quantization noise occurs in pulse code modulation. So in option A and option B, TDM is time division multiplexing, FDM is frequency division multiplexing. These multiplexing techniques In these multiplexing techniques, where multiple signals are combined to form a single complex signal or single composite signal for transmission. PAM, pulse amplitude modulation, pulse position modulation, pulse width or pulse duration modulation these are pulse analog modulation schemes where there is no conversion of analog signal to digital signal. Whereas PCM, pulse code modulation, delta modulation, adaptive delta modulation, these are pulse digital modulation schemes. Here analog signal is converted to digital signal. So in conversion of analog signal to digital signal, first operation that is performed is sampling, and then sample signal is quantized to form a digital signal. So this quantization procedure occurs when analog signal is converted to digital signal. So in PCM, pulse code modulation, we are converting analog signal to digital signal, hence quantization noise occurs. So this TDM, time division multiplexing, is a technique where multiple signals are transmitted over a single channel the time by dividing the time into separate time slots. The total time is divided into separate slots, and each signal occupies a specific slot. Similarly, in FDM, the total bandwidth is divided into separate bands so that each user is assigned with a single band. For this question, correct option is D. Pulse code modulation. Next question. A satellite orbiting at 600 kilometers orbit transmitting 4 GHz frequency, the Doppler shift observed at the ground station when satellite is overhead. When satellite is overhead the station. So correct option is B. The Doppler shift observed is maximum. So in satellite communication, Doppler shift means frequency of the signal received. The frequency of the signal received at the ground station will differ from the frequency that is transmitted by the satellite due to their relative motion. When this satellite is approaching, when satellite is approaching, the received signal frequency is higher than the transmitted frequency. This is when satellite is approaching. When satellite is moving away, received signal frequency is lower than the transmitted frequency. When satellite is exactly at the overhead, directly overhead the earth station, then Doppler frequency or Doppler shift is maximum. It is approaching, Doppler frequency increases, and exactly at the overhead it reaches to maximum. When it is leaving, suppose this is the earth station, in the orbit satellite is approaching towards the earth station, Doppler shift, Doppler frequency increases. When satellite comes to exactly at the overhead, Doppler frequency is maximum, and when satellite is moving away, the Doppler frequency gets decreased. The Doppler frequency decreased. So correct option is B. When satellite when satellite approaches to ground station, the received signal frequency increases. This is known as blue shift. Blue shift. When satellite moves away from the earth station, the received signal frequency decreases. It is called red shift. So let us see blue shift and red shift. When a satellite moves towards the observer, the signal appear to increase in frequency. The signals appear to increase in frequency. This is because the wavelength of the signal appears to be shorter. That is blue shift. Next is red shift. So in the red shift, when a satellite moves away from the observer, the signal appears to decrease in frequency. This is because the wavelength of the signal appears to be longer. So this blue shift and red shift are changes in frequency of signal that occur when satellite moves relative to the observer. And these changes are a part of Doppler effect, which is used in satellite communications and tracking. So correct option here is B. Next question. A discrete memoryless source emits symbols x1, x2, x3 and x4 with probabilities 1 by 2, 1 by 2, 1 by 8 and 1 by 8. Find the entropy of the system. So given 4 symbols with probabilities, symbol x1 with probability 1 by 2, symbol x2 with probability 1 by 2, symbol x3 with probability 1 by 8 and symbol x4 with probability 1 by 8. So they ask to calculate the entropy of the system. Entropy H is equal to sigma I is equal to 1 to n pi log 1 by log pi, that is log of 1 by x will become minus log x. So minus sigma I is equal to 1 to n pi log to pi. So substitute the values on this formula. So we will get 1 by 2 minus 1 by 2 log 2 base 2. So for symbol x1 and symbol x2 probabilities are same, multiply with 2. Next minus 1 by 8 log 2 base 8. For symbol x3 and x4 probabilities are same, so multiply with 2. So that is, on solving, its value is 1.75. For entropy, units of information is bits per symbol. So correct option is 1.75 bits per symbol. This is symbols per second, wrong. Correct unit is bits per symbol. .75 bits per symbol. Next question. Which among the noise greatly affects the communication system at high frequency? So high frequency noise is transit time noise. In communications, this transit time noise is a high frequency noise that occurs in semiconductor devices. So other types of noises are short noise, partition noise, low frequency noise, that is flicker noise, and thermal noise. So thermal noise are also called white noise or Johnson noise. So correct option is C. Next question. A message signal M of t is 2 cos 2000 pi t plus 4 cos 4000 pi t modulates a carrier C of t cos 2 pi fct, where fc is equal to 1 megahertz to produce an AM signal. For demodulating the generated AM signal using envelope detector, the time constant RC of detected circuit should satisfy. So this question is related to envelope detector. So for envelope detector, good performance of envelope detector, the time constant should be 1 by fc less than RC time constant less than 1 by fm, where fc is a carrier frequency and fm is message signal frequency. If time constant is too low, if time constant RC is too low, then capacitor charges and discharges very slowly. It is discharging very slowly and it is not following the envelope. So it is not following the envelope. So the signal is lost. So it will discharge very slowly, hence the output will not follow the envelope. Similarly, if time constant is very high, the capacitor charges and discharges rapidly. So it is charging and discharging rapidly, but it is not following the envelope. It is not following the envelope like this. It is discharging and charging and discharging rapidly. So this too low time constant and too high time constant is not preferred, and for good performance, for ideal achievement, the time constant should be selected for 1 by fc less than RC less than 1 by fm. So from the question, message signal is, so rearrange this expression 2 cos 2 pi into 1000 t plus 4 cos 2 into pi into 2000 t. Now here frequency component f1 is 1000 Hz and frequency component f2 is 2000 Hz. Now message signal frequency is maximum of f1 comma f2. So highest message component is maximum of f1 comma f2. Maximum of 1000 and 2000. It is 2000 Hz. It is 2 kilohertz. Next, also it has been given carrier frequency C of t is cos 2 pi fct. Carrier signal is cos 2 pi fct where Fc is 1 megahertz. Fc is 1 megahertz. Now the correct option is 1 by Fc, that is 1 by 10 power 6, less than time constant Rc for envelope detector, less than 1 by 2 kilo, that is 2 into 10 cube. So here it is 1 microsecond 10 power minus 6, 1 microsecond less than time constant less than 0.5, 1 by 2 is 0.5 millisecond. So correct option is 1. Next question. The signal cos omega ct plus 0.5 cos omega mt sin omega ct. So here it is cos omega ct, here it is sin omega ct. So which kind of signal it is? So it is both AM and FM signal. The correct option is C. Let us see this standard time domain representation for single tone for AM signal is AC 1 plus Ka m of t cos 2 pi fct. If this message signal is single tone signal where AM message signal m of t is AM cos 2 pi fmt, in that case AM signal equation is AC into 1 plus mu cos 2 pi fmt into cos 2 pi fct. Similarly, standard time domain representation for message FM signal is AC into AC cos 2 pi fct plus 2 pi kf integral m of t dt. So this is for AM, AC into 1 plus Ka m of t cos 2 pi fct. For single tone modulation, that is message signal m of t is equal to AM cos 2 pi fmt. This FM signal time domain equation is AC cos 2 pi fct kf am by fm, that is beta sin 2 pi fmt. So for this question, correct option is C. Next question. AM wave with modulation index 0.8 has total sideband power of 4.85 kilowatts. The carrier power and total power radiated nearly is. In the question it has been mentioned amplitude modulated signal. This is related to amplitude modulation with modulation index 0.8. In amplitude modulated signal, it consists of both upper sideband, lower sideband and carrier power. So AM contains amplitude modulated signal contains carrier, upper sidebands and lower sidebands. The total power is carrier power plus upper sideband power plus lower sideband power. So that is carrier power plus sideband power. So for the expression for this total power is Pt is equal to Pc into 1 plus mu square by 2. So it has been mentioned modulation index mu is 8 in the question and total sideband power PSP. So this is power in upper sideband plus power in lower sideband. It is 4.85 kilowatt. Then carrier power and total power radiated is 4.85 kilowatts is equal to Pc mu square by 2. Pc into mu square by 2 is a sideband power. So mu value is, so this is total sideband power. So Pc into mu 0.8 square by 2 is equal to 4.85 kilowatts. So from this carrier power Pc is equal to 15.156 kilowatt. Next, total power Pt is equal to carrier power 15.156 kilowatt plus sideband power 4.85 kilowatt. So it is 20.00625, that is 20 kilowatt. Total power is 20 kilowatt. So correct option is B. 15.2 kilowatt is the carrier power and total power is 20 kilowatt. Next question. The what? This is related to the bandwidths of different modulation schemes, digital modulation schemes. If RB is a bit rate, then bandwidth of amplitude modulated keying, ASK, amplitude shift keying, is 2 times of bit rate. Similarly for PSK, bandwidth is 2 times of bit rate. For FSK, the bandwidth depends on frequency separation as well as bit rate, that is 2RB plus F1 minus F2. So F1 is the frequency for transmitting bit 1, F2 is the frequency for transmitting bit 0. For QPSK, bandwidth is 2RB by log 4 base 2, so that is RB. For any MRA PSK, the bandwidth of binary PSK, that is 2RB by log m base 2. So here in the question it has been asked, if bandwidth is a primary concern, if bandwidth is a main resource, and it is a primary concern, which of the following scheme is not generally considered? FSK, because FSK requires more bandwidth compared to ASK and PSK. Next question, a continuous time function x of t, it is periodic with period t. So given x of t is periodic with period t, and the function is sampled uniformly with sampling rate ts. If sampling rate is, or sampling period is ts is sampling period. So 1 by ts is fs, that is sampling frequency. So we know that Nyquist rate nr is equal to 2 times of highest frequency component of the message signal. So this is an ideal case. Generally, the sampling frequency should be greater than or equal to Nyquist rate, that is 2f. So here number 2 can be written as some integer n times of message signal frequency. This sampling frequency should be greater than or equal to nf. So that is nt less than or equal to fs greater than or equal to nf. So from this, t greater than or equal to nt yes, where n is an integer. Here n is an integer. So from these options, the integer is 1 by 2, 1.2. It is an integer, which is the correct option. Here root 2 is an irrational number. Next question, for a signal with carrier frequency fc is 1200 MHz and bandwidth is 100 MHz, which of the following frequency will cause spectrum inversion? This spectrum inversion refers to a process in which the frequency components of signal are reversed. That is, high frequencies are shifted to low frequencies and vice versa. Low frequency components are shifted to high frequency region. And this is commonly used in communications for secure transmission, speech scrambling, and signal processing. The spectrum inversion in communication is a reversal of orientation of signal bandwidth with respect to carrier frequency. Signal bandwidth with respect to carrier frequency. To avoid this spectral inversion, the sampling frequency or sampling rate fs should be fs is equal to 2fc minus bandwidth by m, where m is 2, 4, 6 and 8 and continuous. So in this case, spectral inversion is avoided. So consider for m is equal to 2, sampling frequency fs is 2 times of carrier frequency, that is 2 into 1200 minus bandwidth 100 by 2, 2400 minus 100, 2300 megahertz by 2. So it is 1150 megahertz. If sampling frequency is 1150 megahertz, then there is no spectral inversion. For m is equal to 4, sampling frequency fs is 2300 megahertz by 4. So it is 575 megahertz. For sampling frequency of 575 megahertz, there is no spectral inversion. Similarly, for m is equal to 8, sampling frequency fs is 2300 megahertz by 8. So it is 287.5 megahertz. So here also for 287.5 megahertz, the spectrum inversion is avoided. So for 287.5 megahertz, there is no spectrum inversion. For 575 megahertz, there is no spectrum inversion. For 1150 megahertz, there is no spectrum inversion. But for 1600 megahertz sampling frequency, spectrum inversion exists. Spectrum inversion will cause. So that is correct option is D. Next question. Coherent demodulation of FSK signal can be affected by using. So as per the key, correct option is matched filter, but also correlation filter. So this coherent demodulation of FSK signal can be performed by using matched filter as well as correlation receiver. Both are correct. This matched filter is a linear filter designed to maximize the signal to noise ratio for a known signal in the presence of noise. So it is an optimal linear filter for maximizing the signal to noise ratio in the presence of additive stochastic noise. Various definitions of matched filter. Or it is a matched filter is a signal processing technique that maximizes the signal to noise ratio by matching filter characteristics to the known shape of expected signal. Next, in correlation receiver, it is a type of receiver used in communications to detect the signals by comparing the received signal with the reference signal. So in matched filter, the signal is convolved with the impulse response. Signal is convolved with the impulse response of a filter, whereas in correlator, the signal is correlated with the replica of itself, but the output of but the output of matched filter and correlator, that is both, is same at t is equal to capital T. So the function of correlator and matched filter is same. As per this question, correct option is both A and C. Next question. What is the required bandwidth of a PCM system for 128 quantization levels when 48 telephone channels, each band limited to 4 kHz, are to be time division multiplexed by the PCM given? So the bandwidth of pulse code modulation is n times of sampling frequency, where n is log L base 2. L is the number of levels, n is the number of bits used for encoding for each sample, fs is a sampling frequency. Number of levels L is 128 given in the question. From this, number of bits per sample is log 128 base 2, so that is 7. So 7 bits per sample. Now sampling frequency fs is 2 times of 4 kilohertz, so that is 8 kilo samples per second. Now bandwidth is total number of channels. There are 48 telephone channels. So total number of channels into, for each channel there are 8 kilo samples per second, and each sample is encoded with 7 bits per sample. Now the bandwidth is 48 into 8k into 7, that is 2688 kilohertz, 2.688 megahertz. Correct option is A. Next question. The modulation scheme commonly used for transmission in GSM. So GSM stands for Global System for Mobile Communications. So Global System for Mobile Communication GSM, that uses GSMK, Gaussian Minimum Shift Keying. So Gaussian Minimum Shift Keying modulation scheme, and this GSM is introduced in 1990, a mobile radio standard of Europe, which uses time division multiple access, and the frequency bands of GSM are 890 to 960 megahertz, and the bandwidth is 200 kilohertz, and this is a cellular or PCS system. So correct option is 4. GSM uses GMSK, Gaussian Minimum Shift Keying. Next question. The maximum length of PN sequence a linear shift register can produce is 2 power m minus 1. PN sequence, pseudo noise sequence. These pseudo noise sequences are used in CDMA systems, third generation cellular systems, for spreading at the transmitter and despreading at the receiver. So this is a linear feedback shift register. So this for linear feedback shift registers of n flip-flops or m flip-flops, maximum length of sequence is 2 power m minus 1. Correct option is D. Next question. Which of the following problem occurs due to adjacent channel interference? So that is near far effect. So near far effect is, it is a phenomenon that occurs when a strong signal from nearby source makes it difficult for a receiver to hear the weak signal from the distant source. Here signal is weak. Here signal is strong. For this case signal is strong. For this case signal is weak. So to avoid this near far problem, the far mobile station is transmitted with high power and the near mobile station is transmitted with low power. So power control mechanism is used to avoid this near far effect. So that is the other definition of near far effect is the signal from nearby mobile station. Here signal from nearby mobile station that is near to the base station may be significantly stronger than, so it is stronger than the signal from the mobile station that is far away, which can lead to loss or significant degradation of signal from the far mobile station. So let us see these definitions for crosstalk, blocked calls and missed calls. So crosstalk in communication is when signals from one communication channel interfere with the signals into other communication channel. And blocked call is, it is a call that is prevented from reaching to its intended recipients. Next, missed call, a call that is not answered by the intended recipients. This missed call is a telephone call that is deliberately terminated by the caller before answering by the intended recipient in order to communicate the pre-agreed message. So for this, due to adjacent channel interference, the problem that occurs is near far effect. Next question. GPRS has following protocol. So correct option is B, packet switched. So GPRS uses packet switching, whereas GSM, Global System for Mobile Communication, uses circuit switching. So GSM uses circuit switching where the resources are dedicated, and this is ideal for real-time voice communication. GPRS, General Packet Radio Service, uses packet switching, shares the resources dynamically, making it suitable for real-time data transfer. So let us see the difference between circuit switching and packet switching. In packet switching, no physical path, no dedicated path is there, whereas dedicated physical path exists between source and receiver. All packets follow the same path. In circuit switching, the packets travel independently in packet switching. So bandwidth wastage is there in circuit switching, no bandwidth wastage in packet switching. No store and forward transmission, if this supports store and forward transmission. So correct option is GPRS uses packet switching. Next question. In a cellular network, widely accepted cell shape is, so generally this circular shape is not preferred. So the reason is, when the cells are divided in circular shape, so some region is left not covered. Here overlapping region exists. So circular shape is not preferred. So in case of square shape, in case of square shape, in case of square, from center where base station is located and to the edge the distance is a by 2, and to the corner the distance is a by root 2. The distance variation is much more, so square shape is not preferred. So circular shape is also not preferred because overlapping occurs or otherwise not covered region. So the only possible option is hexagon, regular hexagon. So this, the regular hexagon shape is preferred because from center to any side or from center to corner the distance variation is much smaller, almost similar to circle, and there are no overlappings. So both problems, here the distance from in square, the distance from center to side and center to corner is larger variation. Here in circle, same distance from all the sides, but the problem is overlapping and non-covered regions. So both problems can be solved in regular hexagon. So correct option is hexagonal shape is preferred. Hexagonal cell shape is a perfect over square and triangular shapes and circular shapes in cellular because hexagonal covers the entire area without overlapping. Hexagonal cell structure. This is hexagonal cell structure. Next question. So Wi-Fi is primarily developed for which of the following? So Wi-Fi is developed for LANs, wireless LANs. Correct option is A. So Wi-Fi stands for wireless fidelity, WAN, wireless LAN. LAN stands for local area networks that connected devices within the limited area. WMAN, wireless metropolitan area network. WPAN, wireless personal area network. So this Wi-Fi is developed for wireless LAN. IEEE 802.11, that is wireless LAN, a Wi-Fi standard. Next question. IEEE 802.16 supports which of the following duplexing scheme? So from here, IEEE 802.16 wireless metropolitan area network. So that is WiMAX, worldwide interoperability for microwave access. IEEE 802.16. So it supports both TDM and FDM. So time division multiplexing for TDM for downlink, and FDM is used for both uplink and downlink transmissions. But in later versions, in upgraded versions, that is IEEE 802.16 and later versions, so from here onwards, OFDM is also, it starts using OFDMA, orthogonal frequency division multiple access.